Hello, I'm Li Hao. So I just got back from work. Take a look. It's dark outside, and I just had a long day figuring out one of a bug that I encountered at work, which I try my best to reproduce in a small reproducible repro over here in the code. Okay. I will share my screen. And so this video is about, as you see in the title, it's about a debugging story. Right? A lot of the times, a lot of new junior developer ask me like, how do you find this? How do you learn things? And then how do you debug? Debugging is very scary, especially when you wrap your head so much and you couldn't figure out like what's going on wrong. And it's a bit hard to share specific techniques or tricks when you don't have any specific scenarios, right? I'm not even sure I have a toolbox of like tips and tricks back in my head. But when I look at things, I have my own way to figuring things out and work my way out to figure out what's going wrong. I think in most of the times when you want to fix something, most importantly, the hardest thing I personally find is to figure out what's gone wrong. Once you figure out the root cause, then solving it is not that hard, because once you understand the root cause, why it is that is not working, then you basically have the solution, right? You know, like, okay, just don't do that, or do another way, or work around, or whatever it is. But to figure that out, to figure a root cause that is convincing and that solves your problem is not easy. A lot of times we rush, we want in a tight deadline, we want to quickly say, okay, we just throw something on top of it and make sure it works, and that's it. But if you throw some on top of it, and if that's not the root cause, then it will appear by itself from random places, and it's just messy and yucky, right? And a lot of times you don't even know what's gone wrong, and you just simply throw things at it and see whether it works. So today I'm gonna sorry for the long-winded. So today I'm gonna walk you through an example that I managed to reproduce over here that I have encountered at work, and hopefully along the way you see the tricks. Hopefully I can remember all of them. I spent the whole day to figure that out, and today in this video, of course, we're not going to record for the whole day. I already know what's going wrong, so hopefully I can jump from places to places to let you see how my thinking process and how I find what's going on wrong. Okay? Hopefully I get my setup correct, and hopefully I can remember all the steps. So from time to time I probably will have timestamps. If you notice, okay, I will add that at the end of the video. I'll add timestamps on specific techniques that I think it's like technique of debugging. Okay, so let's take a look at my reproduce. So over here, at work, we're trying to build our code to we try to build the same piece of code to serve different users for different browsers, like the modern browsers and legacy browsers. So the way we differentiate modern and legacy, we use this technique called module no module. Okay, that's not important in this case, but what's important is that we have two sets of webpack config, two sets of Babel configuration, such that we can, when we bundle for modern browsers, we keep modern features like async await, destructuring, and all this fetch API and things like that. And for legacy browsers, we transpile them to ES5, so that basically non-modern browsers are legacy, right? So it could be maybe some users are still using i.e. Internet Explorer. We still want to support some of them, or older Android browsers and iOS browsers, Safari browsers. So we transpile everything down to ES5 for non-modern browsers. So how we did that is we have roughly like two sets of webpack config. Here is the simplest webpack config that I reproduce, right? One is the entry point is the index.js. So over here, this is our code. Okay, this is not an actual code. This is like I randomly create a lot of things like that. Okay, okay, you will see what I have such a weird file later on. So this is our code entry file. So we have entry, the same entry, but the target is different. So this target is targeting modern browsers. So we have our threshold on what we consider as modern. So all these browsers above is modern because it supports, and all these browsers supports like modern JavaScript API. We use the no module kind of threshold, and these are the browsers that supports ES modules. So we output a file name called the mean output.js. Then for Babel, we use a different Babel environment, right? So this one, the name is called modern, which we'll take a look what is modern later on. And for legacy browsers, we use browser list where we support like any. This is like the like 99.75% of the users and browsers that are not that. We support so basically almost all users lah, right? I'm just copied from this. I copied from the Babel website, probably the browser list website. So I'm not really sure. Maybe we should more than 0%, which means like transport to support all. But I guess like there are browsers that like tiny small group of like 0.025 points of users. They are like all the way back to maybe Internet Explorer 5, 6, or 4. I don't know. Maybe they're still 0.01% of users are using those browsers. Then if you want to transpile down to support all the way back, then probably you have a lot of codes, right? So I guess this is a standard number. I don't know, magic number. At work, we are not using this. We actually know our users and we actually have a slightly higher bar. And for the output, we call legacy.js. So you can see there's two different files. And for Babel, the environment name is called legacy. So for Babel, this is a very simple version of Babel. Basically, we only have one preset, no plugins at all, because the code itself is simple enough. This repro, we don't even use TypeScript or whatever, so don't bother. So for Babel, we have one preset environment. So this is like the preset. It's like a group of plugins, and you can specify some options so that you can configure what is within that group of plugins. Right? So for modern environment, so we use environment. So Babel environment, you have two. One is modern, one is legacy, which is specified over here. For modern build is modern, legacy is legacy. So over here, for modern build, we target browsers that supports ES modules and some of the options over here. And for legacy build, we support targets, which is the same that you just saw. Okay, I could have just copied this browser list over here as well, but yeah, this doesn't really matter about this case. So let's try and build our code. All right, so here if I run npx webpack to run webpack to build our code, now you see in this folder we have two files. And notice this over here. I'm not sure I can, how do I zoom this? But hopefully you can see this, 580 bytes, right? If I select all, you can see 580 characters over here. For main build, for legacy build, it's slightly more, 928 bytes, right? Which is, my math's not that good, but I guess it's like 80% more of the size for legacy browsers and modern browsers. And if you try to format it nicely, you can clearly see why. Right? You can see that for modern build, we use arrow functions. Right? Legacy, we are using functions, so this is more characters. Oops. For modern build, you can I think at some point we are using let's see what's the code that I write. We're using destructuring and we use like rest and spread for legacy. So this one, is it still around? I'm not even sure. But for legacy, it includes much more code like polyfills and stuff to make sure it works. Like things like this. I don't even think we have that in the modern build, right? So modern is supposed to be smaller than legacy. But the bug is this. Let me close this, don't save. We encounter a bug where if I come over here and include add me, this file. If you take a look at this file, I'm not sure if you can see what's wrong. I mean, we import constants and a and stuff like this. And as soon as you build, let me try and build code. You'll notice that the main file is 1.99 kilobyte. And the main legacy is 1.08. Now, it's the other way around where the modern build is almost like 2 times as big as the legacy build. Right? So if you try to take a look at what we have in the code, side by side, main modern. Same thing, we have arrow functions, which is modern build, should be smaller, but somehow we notice that we see a lot of this file over here, constants A, B, C, D, E, F, G, H, Z. Right? This file is the e.js, right? But for legacy build, we don't have it apparently. So yeah, we don't have this. So what's going on wrong over here? Okay, sorry, I just realized that I missed out something. I just jump over to quickly change and come back. So here I added one more thing, right? I just realized that I forgot to add this, so the output looks slightly a bit different, and forgot one point I want to make. So here, I added a dynamic import. Okay, so this makes things much interesting because now in this folder I have 2 files, right? So here, I mean, nothing special. I also randomly create like for loops and something like that so that it looks interesting. So here I have 2 files, the mean and one chunk, right? So you can still take a look. The chunk itself, 790, this chunk ID, this chunk and the legacy one, still this one is smaller than the legacy. The modern is smaller. But again, the main build is bigger than the legacy build, right? This one is 4.4 KB, this is 4.03. Still, we're still having this problem of the modern is bigger, although it's like not 2 times because Webpack added a lot of other stuff. Right? If you take a look, because to support this lazy chunk, hey, where did my code go? Yeah, to add support of this lazy chunk loading, Webpack adds a lot of Webpack code over here, all these things, which makes this code much bigger, and then so the code that is like a code, the thing that is additional is relatively smaller than the overall size, right? Still, you can see that if you compare side by side, the main and legacy, the difference is that you have this place, this module ID 736, where for the legacy build it's only a few constants. For the modern build, it's all the constants, which makes it so big. And yeah, so because the legacy build has a lot of function, that's why the bloat that this added is offsetted by the legacy code, right? So the difference looks less dramatic, but still it's quite a lot, right? So we need to figure out where is this coming from, right? That part I did not change. In Index.js, we're still, because of adding the add me, right? If I don't add this, and if I try to build, then you will see that the main is 3.22 KB and the legacy is 3.79. So it's because of this file, okay? You are lucky watching this because you see me adding and removing files, pinpoint immediately this is the problem. But I did not have that luxury, and my code base is so huge that I don't even know which files that cause. But I do know is that let me try adding uncomment already. But I do know is when I look at the code, it is obvious that the legacy build and the modern build this is obvious to me, where I can see that this is legacy build has only a few like this kind of string constants. Modern build has all this, right? So if you're using React, using some like React router, or I don't know, like you probably have a configuration files with a tons of strings files, or maybe Redux actions. All these, not all of them are being in use. Somehow you have a very big file, but not all of them are in use. And in this case, in legacy build, we managed to perform this thing from Webpack called a tree shaking. Basically, it shakes away exports that are not being used, only retain exports that is being used. So if you search through the code base, you realize that I'm not using the constants G. I mean, not in a this folder, but it's defined in here, but it's not being used. So in this legacy build, it's not included, but in the modern build, somehow it's retained, right? Something is wrong with this tree shaking feature that causes this problem, and we need to figure out, right? So I've seen this, but not all code is written by me, but I have to figure out like where is this code from. So the first thing is a little trick from me for Webpack. A lot of times when we encounter, when you bundle with Webpack, you see that this is like an ID, like a module ID, but you have no idea what this. So here is like one module. Oops. This is like one module, and this is the module ID. And a lot of times you have no idea what is the what module is this. You can of course search this within the code and find out, right? And a lot of times if you look at this, you see that sometimes some places are imports. It's just referencing the function, the value, but it's not using it. It's not a place where it defines it. And sometimes it's multiple layers and levels, and you export and re-export and re-export complex code base, okay, big code base. You can't even find. So we need to figure out what module is this 736. So one trick that I have for you, okay, you can do that now, is in the optimization parts, there's this configuration for Webpack called the module IDs. And it says that this tells the Webpack algorithm, which algorithm to choose the module IDs. So this is to choose this number, right? What's the algorithm to choose this number? But there's this algorithm called name that gives you a readable IDs that is much easier to read than just look at numbers. So first thing is I'm gonna change this, and you'll immediately understand what I'm trying to say. Here I'm gonna add optimization module IDs equals to name, and do both over here. And let's try to build our code again. Okay, let's see. Oops, sorry, let me collapse this. Legacy on the left side, modern on the right side. Immediately you can see that now this is much more readable, right? This is the module ID, which is a named module ID, which apparently it's the file relative to your Webpack build, right? So if you're using some node modules, then it will be node modules, some React or whatever it is. And in this case is the e.js, okay, source.e.js. So lucky you, we've seen that file, we know it's from this file, and that's how I knew it from this file. So this is the trick to find the module ID from the Webpack bundle. If you are coming blindly into a code base and you have no idea where this code is. Okay, so now I figure this out. Next thing is we need to figure out like why is it different, right? So one thing you can see is that you have the t.d. Okay, t is the third parameter, so naming doesn't really matter, but .d and then all this thing. But here in the modern build, you have this extra t.r. What is that? So we need to figure out like why Webpack. I mean like any small detail matters, right? So here Webpack probably figure that this module, and in the modern build, this module is different than this module. When it looks at the same module, it has maybe some marker or some identification that, okay, this is like this behavior, and then do certain things. And of course, and it definitely sees the same module differently in a modern build and a legacy build. And so the output code also will be something different. Maybe it adds some marker because to support certain things that it sees. So must be something that Webpack sees the module differently. That's why it added this line and treat the output this way, and it does not add that line and treat the other way, right? So we need to figure out why is it, and like what is this line? Why? I guess the logic goes by, now we want to reverse engineer and figure this out, right? We want to figure out why Webpack sees this module this way. And to figure that out, we will have to find a place where after they determine that it sees this module this way, it does this thing, right? So the thing that it does different is it adds this line. So we need to find like where it adds this line so that we can reverse up and figure out like, okay, what is the logic that determines that it has to add this line? And probably from there, we can go up a little bit more and to figure out what causes this different and what makes Webpack make such a judgment. So far, so good. Are you following? Right? Hopefully, I think I've tried my best. You can rewind again. Hopefully, I'm not sure whether I should repeat again. I'm facing a camera. I have no idea whether you got it or not. So maybe I try rephrase again. Right? So here, Webpack makes a judgment and determines based on a certain condition. Webpack determines that, okay, this module is the same module, exactly the same, right? But it outputs this code in legacy, but it outputs this code in modern, right? And so it must have some sort of condition. It like matches for legacy and does not matches for modern, or maybe the other way around, right? Does not match for modern. It does not match for legacy and match for modern. So that's why modern looks like this. So we need to find out what's the condition, but like out of the whole Webpack code, how do you find that condition, right? So there will be such thing as, let me type it out. I think I like to type code when I explain. It's clearer, right? So it must have like if some condition, right, somewhere here, and then when you output code, right, when you generate code, right, you probably will add code this line and add code maybe something like this line, right? So this part is quite dynamic, so you probably wouldn't even see it in a code, right? In a code, more probably like you have some sort of some logic over here that is, I don't even know the name of the variable. How do I search? How do you even search this, right? But for this part, I think it's quite clear. I'm guessing it's probably like a string that I can search and then find it out, and then I probably will jump to the Webpack code that has this kind of thing, and then I pinpoint, okay, what causes this condition and trace it back, right? So the idea is to figure this out. So of course this is being minified code, right? So you see that all the variables name even is different. So first thing is let's don't do minification. So at least we can see what's the Webpack generated code. So because we Webpack generates the code first and then runs through a minification, and all the variable name will change. So this might not even be S, this might not even be T. Right, I think .d, okay, this property name is the same, but T and S is just variable name that is randomly generated when you do a minification. So let's disable that. It's called a minimize false. Okay, and let's try and build our code again. Now this time around, the code looks much different, right? You have all this thing, and you can see that, yeah, it looks exactly the same now, right? Webpack require.d, and then Webpack exports. So we need to find where in this place where you have Webpack require.r in the Webpack code. So to do that, we're gonna jump into Webpack code and figure out where. Right, so let me right? So here is like, must be some condition, and then webpack R, webpack exports, right? So need to find this line, then it will lead us to the condition. So to open webpack code, I think it's easier. I mean, if you, by default, if you try to, in your VS Code, I believe by default when you search, it does not really search into the node modules folder. Right? This is good for you so that you don't have to have all tons of search results that is unrelevant to you because it's not the code you write. And also much more performance, does not have to search through the node modules folder. It is configured in certain settings, and we're not going to change that, right? So how do we search things in the node modules, right? So what I do instead is I like to open another VS Code window to look in that code, right? So to open VS Code window, I use the code. If you haven't, if you run code and then it's not a command that is being available in your terminal, then you can actually do this command shift P to open this command prompt and then add code. Sorry, I think it's called. You type code and you will see that install code command in path, and you run this, you will install this for you, and so you can use code in the VS Code in a terminal. So can I say code node modules webpack? So I'm gonna open webpack in another VS Code window, and over here now I can easily search for code. Okay, now you can see this over here, and I guess the one that is R is here. If I try to search, it's only here. Make namespace. Now this gets tricky, right? This is where you pull a thread and then you start to realize that you are going into a rabbit hole where the thread is keep pulling and it's get longer and longer and longer, right? So we found that the only place that has webpack R is this. Right, it defines, okay, it's a small r, so it's a make namespace object. So now we need to find where do we use the make namespace object and get a ton of results. Okay, I mean, I think there's some capital M which I don't think it's correct because our exports is lowercase. So let's do a case sensitive search. Sometimes that helps. A lot of times you have a class that is like car, and then you look for a class called car, and sometimes you have instance called car, and then you want to search for a car rather than all the small instances of car. Then case sensitive helps in searching code, right? Maybe that's a tip for you. So next is, okay, we have less results. This ignore, okay, because this is the place that we start. Over here, not really using it, right? I guess, hopefully we're not. I think this is more interesting. This is where it has this thing, right? I mean, this code and then bracket and then exports argument. I mean, this looks like this thing, right? So let's keep that in mind. Let's see whether any other results, search results over here. We have this, which looks similar as well, and then define getters, right? Namespace object. Do I have that in our code? Not really. Okay, I mean, this is the code that is generated, has this comment. We didn't remove any comment, right? So probably it's not this part, this function over here. So next we're gonna look at the create fake namespace. Again, this is ns, and then this is like object create, so it's not this one. And here it is, okay, this function. And then this function is equals to, okay, so this is where it defines this function and equals to something, I don't know, but it does not look like what we are looking for. And here, okay, here we have WASM exports and instantiate assembly module, not like what we're looking for. So I guess we are back to this runtime template. Now, pull once, we have more. So now it's definitely in this one because we've exhaustively run through every possible places, and this is where we are using. So let's take a look at where we're calling this. Much better, we have less code, which either, this is TypeScript definition, ignore. This is where we are looking from. So here it's either content like this one, and then init fragment and whatever it is, or whoops, sorry. Wait, is that define ES module fragment? Or here, with a ESM compact flag, right? So do we have this in the code? No, we do not. Okay, so I guess probably it's not this concatenated module, but it is this one, the init fragment. Okay, so now here is where you roughly see the form that I just told you, right? If a condition, then do something, right? If a condition, then do something. So we want to check where so probably like a condition for here is true for the modern build and it's false for the legacy build, something like that, right? So so we are going into here, right? Now this gets tough. So I think here what I would do, or I did do, I can't remember what I did. I did a lot of things. I tried a lot of things when I tried to debug. Okay, now we are like going through the same process. But as I vaguely recall, this is what I did. You can try to prove over here. You can try to console this out, this value, right? Okay, so here, usually I try to type a lot of nonsense that it's like obvious that I'm printing out this line. Although like when you run this build, there's not a lot of things in the console, but sometimes with a bigger project, you have a ton of things throwing out in the console log, like, warnings or whatever, not a lot of useless information. Useful information if you know what to look for, and useless if you have no idea and you just throw in at you, right? Something that we need to improve on. But so this is like a force of habit. We add something here so that it's clear that it's printed out from here, and then maybe like this thing, right? I just print out this condition. And let's try and build our code again. So here I modify webpack code directly. And if you build now again, you probably will use the updated code immediately. For webpack, you don't have to rebuild or whatever. And this is the code that you download in your module, and this is the code that will be run. Right? So you just run again. And okay, lo and behold, you have true, false, true, true. Right? So I guess for legacy build, you have that. I think the false comes from legacy build. So this is the different, right? I don't know, maybe for some case it's still true, but for at one case it is false, and that's why it is different, right? Hopefully you can see that true from modern, true from legacy. Well, I can't really tell. Okay, this is, I guess, and maybe I'm guessing wrongly. So how do you determine that? Well, you just run one at a time, right? So I comment this out. So now I'm running the legacy build, and if I try to build, it's a false true, okay? And if I switch the other way around, comment out the legacy build, and it's true, true. So now this is where it's different, right? So and it makes sense, right? If it's false, then you don't fall in through here, so you don't have this thing, and it looks different, So this is again like need to figure out why, okay. So exports info, okay. I think I'm seeing like some useful type definition over here. Exports info. I'm trying to jump in and see whether I can find something out of it. Okay, so exports info. It calls get read only and get use, right? Get read only info and get use. Oh no. Get read only exports info, returns export info, and then get use is something that we'll need to figure out. Then a ton of logic over here. So how do you even figure out? How to start? I mean, I'm guessing like some of this, like global use and use runtime, and I mean these are the variable that determines, that is part of the condition that determines whether it's true or false and stuff like this, right? Hopefully you can see that. I mean, it takes time to narrow down what it matters and what does not. And my rule of thumb over here is that it boils down to this, right? You have this class called, I'm gonna call AAA, right? And then you have this function called get read info, return something, and get use, right? So this value it compares over here. So if you have a function that looks like this and takes in like something called a runtime, and then you have if condition of this dot blah blah blah, and then maybe like return runtime equals to something. This dot something like this. If you see code like this, so there's two things that like two kind of variables, right? One is one is the AAA itself. Internally, the state is different. So if you pass in the same, so for modern build and legacy build, what's the different thing, right? What we want to figure out, right? One is either the state of this AAA, the instance, is different, or the parameters you pass in is different, right? So it's either the get use is different or the runtime is different. So you can place your bets, and you can of course debug one by one and figure it out. And I'm just gonna place my bet is that this dot the internal state this dot whatever it is might be different, right? So I mean I might be wrong, but if you want to exhaustively try out all the different possibilities, try something that your gut feeling tells you that it's a higher chance of correct, because if you hit correct first, then you don't have to try the other one, right? I mean, so trying out in your head, if you try to list out all the possibilities that could go wrong, right? Could be runtime is different, could be this.xxx is could be this.xxx is different, could be this.yyy is different, right? It could be all three, right? You definitely have to try all three to, I mean, in your mind, if you lay out all three possibilities, try and log out one by one and see what's compared by one and see what's wrong. But of course you don't have to. You can prioritize the more guilty, more suspicious one first, and then you try something less suspicious later on. And I'm gonna place my bet on this because I just feel it. It's just a gut feeling of after debugging for a while, right? So another thing you can try is also log as many as you can, like something like this. Maybe it's this one, I don't know. And maybe it's this one. And what else is this dot? I mean, oh, okay. They're almost the same. So it could be, this tree could be something different, right? And of course you can log out runtime as well. But I'm just gonna place my bet on something with this first. So if you try to print this out, let me go back and try to print it out. It's a bit nasty or a bit hard to wrap your mind sometimes. And I find this tips a lot and often, a lot of times when they say, stop using console.log. It's not when you're debugging, you should use this and that. And I mean, sometimes console.log is the fastest. Why not use that? But there's one tips that I found that's useful in console.log is that we try to print 3 values side by side. If you can wrap your mind around this and remember what is false, what is undefined, good for you. But if you can't, so my tip here is to make it an object. Sometimes it's a bit easier if it's an object. And so something like this, I will keep the name entirely. Something like this. Okay, so if it's an object, then it's much easier to know which one is which. So if I try to run again, if you take a look over here, you see that this log is, albeit it's a bit too long, but it's nonetheless it's easier to glance through, and it's easier to tell like, okay, this is this one, and this is undefined is a global use, and use in runtime is another one. So, but you have a ton of them, right? And I don't even know where to start, right? So now the next tip is that you need to find out when to console.log. You console.log when it matters. You don't have to console.log in this function, especially I'm guessing this function gets called a ton of time. So you don't have to get use every time. So we need to figure out when to call the get use. And so here, so it's my point. So here it's like you need some condition to figure out when you're actually interested in, and then only you console.log, right? This will save you. This will much easier for you to glance through at where's wrong, right? So we probably want to call the get use, or try to like get read and export info of something of a, I mean, from the name exports. Maybe we want to look at the exports of the of this module, of the, what's the module? The name again? The EEE module, right? We will probably want to look at the exports of this module, but how do we even filter that out? I mean, I have no idea. Even I had, because I just debugged it this morning, but assume I don't have. What should I do next? I mean, you can try to make sense of the code, look up, look down. I don't know, maybe module. But if you try to log module, fair warning, if I try to log out module, wait. Okay, not this one. I think it's exports info. Does it have module? Oh man, I don't even know whether it has module. It does not have module. And if you try to print out module, you will be shocked by, oh sorry, I should remove that code, because we haven't figured out what's the condition. Okay, let's remove this too. You try to run this, you'll be shocked by like module is this whole big object that I mean, how can you even look at this, right? But since we print that out, and I realized that I can see like user request or something like resource is the full path of the code that we are looking at, then I guess we are one step closer. Let me just comment this out first. we are slightly one step closer. Over here, we don't have to print out everything. You can maybe if the module dot resource is equal to this, I mean the E, only let's print this out. Console.log, I think, okay. I mean, I'm going for a console.log module, so we don't have to print out all the modules, but let me comment this out first and let's take a look at what we achieved so far. Right, so here, let me clear. Let's run this again. And you see that previously without the condition, we printed 2 lines, right? True and false, false and true, something like that. Now we only have 1 line, right? So we kind of narrow down, and we probably want to narrow down again for when we call the get used, okay? So in get used, we need to figure out what's the condition so that it filter down. It's a bit hard to read the code from here onwards, so let me show you with another tip that I have. So another tip that I have here is, now, don't be scared about, I mean, you see me digging through things like nobody's business. So first is, like, if you look at here, this monstrosity of webpack source code. Do I understand everything? No. Do I even understand what is in this file? No. But I have this audit, like, after a while of debugging code, you have this, you slowly build this courage on facing the uncertainty, because even if you after writing a ton of code, you may even forget what you've written, and you may be looking at unknowns, right? So don't be afraid of looking at tons of code that you have no idea, and don't be afraid of like trying to digging things out, right? So far, I hope that we've been going through the logic so far so good, right? How we end up here is we found this line, right? Define ES module flag statement, and why is because we pin down, like, from this output, right? We're saying that definitely have certain condition that it causes this. So we need to find out where we add this first, and then we can find the condition. So we found that this is where it adds, and this is the condition, and that's how we pin down that, and we console log and realize that, hey, it's the right condition. And in real life, it's much harder because you see a tons of like lines, and you don't even compare, right? I mean, the repro that we had just now only print out 2 lines, and without this module, like this condition that filter out exactly the right place, I don't think I could even. It's not that easy to pin it down. It's this, and you can immediately tell it's this fault. It's this condition is wrong, right? It took me a while to go around, but I mean, in a smaller repro, you kind of see like this logic flow. And now, what we need to do next is from here, need to go and see what's the condition when you call the get use, right? And so now it's time to step up again and try to don't feel afraid of using the debugger, the Chrome DevTools, right? To spin up Chrome DevTools in node modules, right? So this is how you do it. So when I run npx webpack, what it does is that it actually goes to the node modules folder, the bin, and here's the webpack. So it's actually the same as node modules .bin webpack. It's actually the same, right? You see, it's exactly the same. But doing it this way has an advantage, because now you can pass in flags to the node command. You can say node inspect, and I like to pass in inspect-brk as well, because this will this will set a breakpoint at the very beginning of the line, so that you'd have your time to open your Chrome inspector. If you just inspect and you haven't opened your Chrome inspector, then when the whole process is done, it's done. You don't have a place to like wait for you, right? So I pass this flag as well to break at the beginning of the code, and then I pass this, right? So I run the same thing. I run webpack with 2 flags, and as soon as I run this, you see debugger is listening, and then it's paused for me to open my Chrome debugger. So here I'm gonna have Chrome inspect, and you can see immediately I have a remote target over here. This is where I'm debugging from, and I click inspect, and you can see now I have my debugger paused, waiting for me to start, and I can hit play and look at the console. I think everything is done. Yeah, it's done. I forgot to set a breakpoint. Right, so here you can set breakpoints you can set breakpoint over here like this, but probably you have to run this VS Code. You have to run using this over here and specify the command to run, which I seldom do, so I'm not really familiar with how to do it, to be honest. But I sometimes, most common, I use the debugger statement where it will set a debugger breakpoint for me as well. So I run this. Wait, sorry. What is this? No, doesn't say. We're trying to node and come over here to my debugger, Chrome DevTools. What is this? I'm not really sure. Wait, hold on. Oh, right. Sorry. Looking in the wrong place. Node inspect. Inspect. We are here breaking. We run. Here we hit this condition, and then we hit our debugger statement. Now here we are paused. So now we want to step into this function, right? So we hit, use this one to step over, and now we are at this line. We want to step into this function. So this is the into. Now we're in here. Name is ES module. Okay, I have no idea what this is. But I mean, while we are at here, we can see that this self refers to exports info, and you can try expand and see what we are looking for. Name exports. Okay, these are the list of exports. Exports are ordered. Other exports info. Redirect to site effects. Info name. I don't know. Okay. Let's get out from here. So here I think we can step next. Info is undefined. We can also step out, right? And then we are at this. We've evaluated this. Now we are at breaking at here, get used. So let's step into it. And here, we see that this is true. But let's take a look at here what we have. The runtime is called main. Okay, keep in mind, maybe we need it later on. And that's it. I guess that's it. I don't even know what's useful to be able to differentiate different export info. So let's see. This is where I guess it's returning something, right? It returns a value which is unused, right? Man, I need to step back. Okay, so here, once I'm out, I can't go back in. I have to play it through, kill it, restart again. Yeah, this is life. So here, let's quickly do that. Let's see what we can do over here. Inspect. Let's run. We are here breaking module. This is exports info. Module graph.get exports info. And then read only and get used. Step in. So the name is called ES module somehow. Okay, I'm not sure is it useful. And then when we get exports that get name, we get the exports info, right? Get out from here and get in. This is the export info. And do we have anything? I I thought the name would be something that's similar, but apparently it's not. Okay, so apparently nothing interesting that I can see, but I can see that the can mangle use is false. Let me record all this down. Okay, let's record it somewhere here. Okay, so this one is when we are building for the modern build. Okay, modern build. Now let's try and see what do we have for the legacy build instead. So let's comment this out and uncomment this instead. So let's try and run again. Let's try run again. So let's go in. Now we are at this condition where we are at this module. We go in and then go in here, out, in again. So now we are like export info, and let's expand this and let's copy this out and let's see what's the difference. Right. Oops, let's collapse this. Legacy. Right, and let's open side by side. And you can see this is true. This is different. Can mangle use is different. Right? Everything else kind of be the same. Right? Can mangle use is different. Now the next thing is now we so a lot of time like this kind of debugging is like spot the difference. Left and right. Right? So here so let's recap a bit. We basically found that the place where we know the condition where it's going to be different is here, right? We figure out that module resource is like this, and I think you can see the difference. Hey, wait, let me. Where is the code? Oh yeah, here. You can see that this is printed out false, this is printed out true, so this is where it is different. Right, so exactly at this condition we found is different, and then at first we were trying to see what is the condition. We print out some useful information and figure out like why, but here we kind of realized that we can't even find what's the condition, but it's okay nonetheless. When we hit this condition where it's going to be different, we use a debugger to basically step into this function. And then instead of logging things out, we rely on our debugger to find out, like, look at the scope, like this local scope of this value, and then we copy everything, right? I think we were supposed to look at global use has use runtime info and use in runtime, right? Has use in runtime info is the same. Has use in runtime is undefined. And we did, yeah, use in runtime is undefined. Okay. Jumping too fast. Console.log again. So has use runtime info. Has is true. Right? So global use is undefined. And use, so it's not undefined. Okay, if it's undefined, then probably somewhere use in runtime. Somewhere, somehow we have our code that executes and returns something different. So we found that can mangle is different, but can mangle use is different, but somehow it's not part of the code that we see here, right? If you try to zoom out, right, this is the code that we are looking at, the condition, and if you search for can mangle, it's somewhere else. Not this function, right? Not this function that we use the console log. So now Now again, then you will have to try to link the two. Maybe can mango use is not the thing that we look at, right? So here what we can do is, since we are at our debugger, we can step through and figure out where it exits from this get use function, right? So we can just step one step at a time. So use in runtime here, and then exits from here. Okay. Okay. So so let's remember that, and let's try and run again with the modern build. So here, let's come back again. Let's try build again. I think this video is getting very long, but we will get there. Debugging is like that, right? So here, I jump here, go in, step in, out, step in. So here we are. So just now, remember, we are exiting from here, and now let's try and see. Okay, we didn't go through here, so use in runtime is different. Oh, use in runtime is different. What I didn't even notice just now, right? Use in runtime is undefined, and use in runtime is I didn't show that. Okay, so it's use in run. Where was I? Okay, so use in runtime is different. Use in runtime is different. Okay. And then, sorry, switching too fast. Okay, here we are. Now we step through, and then here, use in runtime, get runtime. And then we are here. And I guess the value is something. So we are having something, right? So now question is, use in runtime, it's like a map. So when do we insert things into this map, right? So we have to, work our way back. So dot set, it's a few place, set use over here. It's still set use over here. So use in runtime dot set. So here, and here, and here, and here, right? Ton of places. So again, we need to figure out which one, where is it. So the way you can do it is basically set breakpoint in each of them. Okay, it's lame, but that's kind of it. But you can see that this is a map, and this map we set main, right? We set main to something. So again, if you don't want to have debuggers in everywhere and basically keep tripping you and every time, let me show you how it feels like get tripped every time you are running this. So here is this function, debugger, right? Debugger. Here. Right, so if I try to run this, if I try to have this instead, right, let me show you. If I have this, all the debugger at every point possible, then it's kind of annoying when you try to run and then you keep basically tripping here, and you're not even sure whether you are looking at the right place. You trip, keep tripping, and you have to look at here and there. But as I learned, there's another trick which is called a watch. Here, what you can do is actually you can add variables. So for example, you can add condition, right? Variables here, like condition, new value. You can hover and take a look at their value, right? Something like that. And you can also have it here, then runtime. One way is like this, so that every time when you trip, you can look at the value and try to see anything. At least you can see this is .use, this is something else, and things like that, right? But nonetheless, you still feel like it's annoying to get tripped at all the places, and yeah, this takes time. After a while, you realize, okay, this is not the right way of setting a breakpoint because it's not good. So you need to have conditional breakpoints. So let's clear those. I mean, the runtime is mean, right? We can set runtime. Hold on. We could also even know like the value, right? Because use in runtime we set a new value. So runtime equals to main and new value equals to 3. I remember it's 3. Then we set the debugger. Okay. Let's see where's our other debugger. And I can show you another way of setting a conditional debugger that does not involve. It's more like involve something like this, where you can do this thing, but on the DevTools. So let me show you. Let's see. Let's clear this first. Let's end this and let's start again. Right. So when we start this, inspect. Here, what's the file again? It's called webpack. What's this? Okay, I think, yeah, we need to run some code because some of the code are dynamically imported. That's why there's no breakpoint. So here, we used to set a breakpoint here everywhere, right? But you can set a breakpoint and right click and say edit a breakpoint. And here you can set it to be like a conditional breakpoint, meaning you can add condition. So condition like runtime equals to main and new value equals to 3 as the conditional breakpoint. So we have the set use conditionally. Set use, we already have it. Set, I think there's a set use. Use in runtime. Use in runtime. Hey, where was it? Remember, I have another one. Use. Only two. In unknown way, right? Here we can again set continue set conditional breakpoint, and I mean, wait, this does not set stat. Okay, never mind. I think maybe we're not hitting that. So let's run again, continue running, and then let's see whether we hit any of our breakpoint. Wait, is it ended? Somehow it does not hit any of our breakpoints. Set use. Oh, okay. It runs early, a bit ahead of time. So here we have use on 3 runtime value mean. So we are here, and then where is it? I think probably somewhere we are. I guess we need to figure out why this is being called set use conditionally in the first place, right? We run through this code, and probably in different kind of condition you have the set value. right? Most likely than not, you are setting the value main to 3, and then that's the thing. So to figure out who called this function in the Chrome DevTools, you look at the call stack. So call stack is like you call A and A call B, B call C, C call D. You are breaking at D, but you can actually go one step back at C and B and A at the point where they're calling the, you can go to the C where it calls D, you can go to the B where it calls the C, it goes to the B, A where it calls the B, right? And that's the call stack. So if you look at the call stack, you can see that, okay, actually I'm calling the set use unknown way over here, and call the set unknown condition, set use conditionally. And here when I go up, and I keep going up, and you can look at all the things. Over here, if I look at the module and reference exports, so here I'm going to cheat a bit because I realize that this is going to be too long. Here, if I break this and if I set conditional breakpoint, I did breakpoint as the module. Module, I think, is the resource again. It's the F. Wait, hold on. Module resource should be E, right? So probably that place was hit twice. Let me try run again. Okay. I think we play and then over here module. Sorry, module resource is F. I mean, it's hard to look at, so here we can do the module resource. It's E, right? E and F, right? Here we are at E, and the reference exports is an empty array. Okay. So if you keep going and figuring things out, you probably will. I realize that I'm probably gonna reproduce a whole day of debugging. One thing I found out is that reference exports is an empty array. In this case, and as compared to some, like reference exports is something that you figure out. Let me see. I think we've gone through all the tricks that I have. Let me try to close this inspector first. To be honest, we gone through all the different tricks, like pinpoint where to find, how to log things, how to do conditional logging, breakpoints, conditional breakpoints. Here, I'm gonna cheat a bit. I'm gonna go process. Where's the process module? Process. And I say searching, you can use the here, right? If I over here, if the module resource is equals to this file, okay, I can try run again without the debugger. So, whoops, hold on, where is this? Oh, webpack, sorry. If I run this without debugger, you will see that the reference exports. There's a case where it's an empty array. But basically, this is telling like webpack that what are you referencing to. Sometimes it's like I'm importing these two exports from this module, and sometimes importing A from this module, sometimes this, sometimes empty array. And if I'm in an empty array, let's see. If I'm here, if I'm at whoops, if I'm in here, and then if the length is empty array, then I will call this, and then call this, and then do something. Okay. I can't remember how I figured that out. But I noticed that there's one weird place where it shows an empty array in the modern build, but in the legacy build, it can clearly shows all the exports, right? And I can't remember how I figured out that when it's empty array, it's it's causing the problem, and then that leads me to find out why is it an empty array. And when it's empty array, let's see, it does this thing called that it will, if it's an array, it will reference here, right? And length this, then you have the here, right? Over here you set conditionally, and here we set the use in runtime, right? Well, I can't really remember, and I guess I'm gonna disappoint you guys here that oh wait, hold on. Here, wait, let's try run this first. Console.log. Again, if always do this so that you don't have too much logs. Oops. Let's try run this. This is quite a lot of logs already. I mean, this is the actual exactly the same thing for modern build. I figured that this use exports is, it is an array of an empty array. Okay, it's still something. It is still something, and you will still go in. And then here is the length is equal to 0 that's being run. And then this is where it calls the sets in unknown way, right? And that's where you get the, this is something that It's like webpack says, I have no idea you are being used in an unknown way. And yeah, and at that time I'm like quite baffled about like, what do you mean? Why do you even know this is being used? Or like, who determines like what is being used, right? Over here we keep talking about this E modules that is like exporting this and what is being referenced, but who is referring them, right? Who is importing this E module in such a way that is like used in unknown way, that it has no idea which exports is being used, and thus trigger this whole thing like to say that, okay, I need to include everything, right? So that's where I was like, I need to find out who is referring them. And again, this is like a sea of code that you have no idea where to look for, but you build this map of the module and reference exports, right? So who builds this map, right? And then we go up, and then we're like, okay, and this map, I'm like, it's a ton of code again, which I am not willing to read through them. But one thing I can tell to you is that from here, I see this function is being called with a module again, right? So this module is probably the module that's referring to them. Maybe, I guess, maybe, right? So which module, right? So like if you're at me, if you're looking at e.js, so many places are importing and you're marking like all of them is being exported, like who, right? So here I'm like, okay, what if I long this out? So here is like console, here I have module, here I have module, then I can't refer module here, right? I basically want to print module out from here, but I can't refer to here. So I set it to another variable, like we call it __m. Just trying to have a name that's unique. I guess like _m suffice. So do this, and this is the module. Probably I can .resource is good enough. And even here we see a lot of console logs, right? So what if I can check for this, right? What if and reference exports.length equals to 1 and reference 0.length is 0, right? And let's try to print that out. Okay, and that's what I did. In a roundabout way, in real life, I spent a lot of time figuring that out. So, but ultimately it's something like this. And when I run, I found this place where it says add me. Alright, this is the culprit. Okay, the rest it's innocent, and this is the culprit that is like is different. And if I try to keep this and run the legacy build, and then I see that, you don't have that line because the condition is not met. And so now I see like, okay, is this guy, okay, this guy is causing me problem, and let's try and try to look at the code in this guy. What is wrong with you? Why? And I don't know how, but it chanced upon me that, we know that we are importing constants, and somehow I saw this line where we are destructuring this thing. I was like, is it because of this that you have no idea that is being used? There's a lot of things that I missed out, but in this reenactment, but I did like when the webpack is trying to build up the reference, like what is being used, it actually looks through every place of use of the constants. It actually looks at here, it looks at here, it looks at here, it looks at here. So there's a huge array of things, and imagine you have so many imports and so many places using them. It's like, it's hard to find. But somehow I realized that something is wrong with this line, man. And it's like, okay, what if I change this to look like this? Okay, what if I change it to look like this? And try to run this again. I mean, okay, I should run it in modern. And it's gone. I mean, like it's gone. Like it's like, okay, I know now. You are using this exports from this constants, and I understand it, and I can do tree shaking for you. And then when I look at the code, man, it's like, wait, is it this one? Hold on, did I build correctly? Hold on. Let's wait. I did. Wait, did it? Did I? Still includes every. Oh wait, it does include everything. But this thing is smaller now, and if you try to minify, all the variables that is unused will be thrown away, and then you don't see them anymore. Remember, before that, this looks different. This is like a huge list of functions. Let me try to remind you again. Let me comment this out. Oops. Let's see. Like previously, it looks like this. It looks like this. This is like huge functions, and after we change, it looks like this. I'm like, oh wait, hold on, I need to build. It looks like this, much smaller. And if you minify, it's actually a smaller bundle than the legacy one, right? I mean, let's just might as well do that. Let's see. Webpack config. Let's try to remove this too, and undo all the non-optimization thing. Let's try run build again. And then we immediately see that this is 3.36 kilobyte. This is 4 kilobyte, which is great. Which you don't have this anymore, and it's much smaller. And it's like, oh my god, man. I mean, who knows that? I mean, how do you even know that this thing is the problem that causes like Webpack to de-optimize and then figuring all this out? And it's a good day that I finally figured this out. And now I'm like, okay, I know what's the problem. So I go and search. I just like, okay, tree shaking the structure Webpack. Is there a bug issue? And wait, I think I somehow found it. Webpack code. Issues, tree shake the structure. And I found this issue, and it explains exactly what I have. It says tree shaking when using namespace object. It's not supported, and it's like a feature request to support this. I'm like, man, finally. So easy way to do this is probably change the code, right? Or write a Babel plugin that transform this into this. Well, so this is where I'm gonna plug my blog about writing Babel transform step-by-step guide on how you would do that. Tell me if you're interested in like watching me writing like Babel transform, custom Babel transform, and stuff like that. I mean, you can read this or tell me whether it's a good idea to make a video out of it. Of course, I'm not going to do it now because it's it's a long video, right? So let's summarize what we've gone through so far, right? First is to always compare and figure out like what is different, right? We compared the modern build and legacy build, and we found the differences. And then from the differences, I mean, code always, like most of the time it works this way. It's always it's always a if condition and does something different. If something does something different. So let's try to look at what is different over here, and then by looking at what is different, then we can pinpoint to find out, like we can find something that we can grab and search, and then from there we recursively trying to pull to find the condition, right? It could be multiple layers down, but eventually you can still find the condition where it triggers this if condition. All right, once you found the condition, then now, because this piece of code may be run a lot of time, right? You can add console.log to log out the condition, or you can maybe add debugger to pause at the condition and pause inside the condition, where when this condition happens, you debug, you have a breakpoint, and when you in there, and if you run and you realize that this debugger is being tripped by a lot of times, maybe a lot of modules have this condition meet, then you have to figure out how to scope it down, right? So you have to figure out like maybe another condition to trigger the breakpoint, right? So here we can have the code debugger, or in the dev tools you can set conditional breakpoints. So you add conditions to break your breakpoints, right? So either you console.log, right, or you debugger, right? So that's like the useful tools to always do. And if there's too many logs, add conditions, conditional loggings or conditional breakpoints. And when you reach those things, and then slowly to try to think in terms of logic to understand the logic, right? So if condition, and then we are at this place where we look at reference exports, and then we realize that, hey, these are all the exports that you are trying to mark, right? And from there we try to so in DevTools you have ways to walk up the scope and walk down the scope and see who is calling this function and trigger these things. And we kind of skip that a bit, but we look up the scope and realize that it's actually called in a function called reference modules, and here we see a list of reference exports, and then we find that, okay, hey, this mix, we try to understand the logic, and we're like, hey, probably this is where it is. So we go into reference exports, and then we are say like, okay, print those out and see what's difference. And then we realize that again, right, we have to always compare the differences. And so if I have the modern legacy build, which is like different, we compare the difference, right? And sometimes it's like working code and non-working code. So you have to have a way to set it up nicely such that you can run this and run that at the same time, or run it parallel at the same time, and then look and compare. And if you print out too many things to compare, add conditions so that it's less thing to compare. And then when you compare, you realize something, and then from there you try to understand the logic and try to print more things out, right? So hopefully this helps. I will definitely see whenever I have encountered any tricky debugging things, and then I will try to and if I can remember all the processes like this one, I try my best. I will try to make videos like this, so that like it's really, you need to really go through step by step, and then like, this is how, and find that out. And if you like this video, give me a thumbs up. If you learned something, or you want to ask me something, feel free to comment in the section below. And I mean, not just thumbs up. If you really like this and you want more of this, smash the thumbs up button, comment, say want more, okay? And I shall see you in the next video. Bye bye.